Light is the fastest thing in the universe, and it's famous for one strict rule. It travels in straight lines. It doesn't do curves, and it definitely doesn't do U-turns. Or does it? Today, we're going to break the law of physics, or at least, look like we are. We're going to bend a beam of light using nothing but a bit of H2O. This isn't magic. It's a phenomenon called total internal reflection. When light tries to move from a dense neighborhood, like water, into a thinner one, like air, it gets refracted. To be precise, this bending is governed by something called Snell's law. It's a mathematical formula that predicts exactly how much light will bend based on the materials it's passing through.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Tells light, if you're going from water to air, turn left at 48 degrees. Without this formula, we wouldn't be able to design lenses, cameras, or even glasses. But if you hit the exit at a shallow enough angle, the air basically says, access denied, and reflects the light back inside. According to research from the Optical Society, this happens because the water acts like a high-speed lane that the light just can't quit. We aren't the first to find this cool. Back in 1841, a scientist named Daniel Colladon used a water fountain to prove light could be guided. He showed that as long as the light keeps hitting the edge of the water stream at that sweet spot angle, it stays trapped. It's like a cosmic game of pinball where the water creates the walls. Fast forward to today, and we've traded water for ultra-pure glass. These are fiber optics. But making these cables isn't easy. It starts with a giant glass rod, called a preform, which is heated to over 2,000 degrees Celsius. It's then pulled or drawn into a thin strand, like pulling taffy. This process has to be perfect. Even a microscopic dust particle can scatter the light and ruin the signal. That's why they're made in ultra-clean rooms cleaner than a surgical operating theater. Every like you send, every video you stream, is just light bouncing millions of times per second inside a glass thread no thicker than a human hair. As noted in Nature Photonics, this tech is why the internet can move at the speed of, well, light, even across the bottom of the ocean. And it's not just for the internet. Doctors use this same light-trapping trick to see inside the human body. Endoscopes are basically bundles of these optical fibers. They carry light down into the stomach or lungs and carry the image back up to the doctor's eye. So, the same physics that lets you stream movies also helps save lives. Looking ahead, scientists are even exploring hollow core fibers, where light travels through air instead of glass to move even faster. We're pushing the boundaries of Daniel Colladon's fountain further than he ever imagined. So, the next time you browse the web, remember you're relying on a trick discovered with a leaky bucket and a dream. Light might love a straight line, but it's much more fun when it bends. Now, here's a thought. If we can trap light in water, do you think we could ever trap it in something even crazier, like a cloud of gas? Let me know your wildest theories in the comments below.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.